All right, welcome everybody. Thank you for showing up to another one of my presentations. I do see some familiar faces, so I hope I guess I haven't bored you completely this week. Today we're going to build on a little bit of what some of the things I've talked about at the previous sessions. But if you didn't make it to those, they weren't necessary. They certainly weren't a prerequisite. We are going to different topics. It's just building upon some of the other things we learned, but you can absolutely take a lot away from this without having gone to those. So we are going to talk about build pipelines, specifically for OpenEdge today. And I wrote with Docker. Docker is an important component of how we're using build pipelines, but it is certainly not required. A lot of what you see here can be done without Docker and other methodologies. The idea really here is build pipelines, why they're important, how to use them, and what benefits you may be able to gain from them. On this slide, this will be in my GitHub repo. You can find links to me. You can come talk to me. You Google it. I'm sure that repo or that organization or repo will come up. All the code that we're going to look at is shared there. Nothing too fancy, but you're welcome to use it on your own build pipeline adventures. Real quick about me, if you were in my other sessions, I promised different dog pictures every time, so you get a new one here. That's what they do during the day, about lunchtime. They don't even eat lunch, but somehow they know to annoy me at lunchtime by putting themselves right where my feet go. I currently live in Tampa, Florida. It's much warmer than this has been here this week. Before that, I lived in Bethlehem, Pennsylvania. I've been writing code my whole life. It's the only thing I've ever been any good at. But they've been paying me to do it since 2010, which was also the first year that I experienced OpenEdge, and I've been working with OpenEdge ever since. I certainly work with other technologies, but that is my bread and butter, as they say. Like some people in this room, I started my career in ERP at a little company called Apprise Software. About 6 years ago, 5.5 years ago, I transitioned to the company I work for now, Rocket Mortgage. And I'm currently there as a staff software engineer, and that's financial. We're in the financial industry instead of ERP. So while it's wildly different types of transactions, at the end of the day, it's still transactional type software. There is a lot of overlap between the two. And those are the two dogs, Maya and Lily. So. Let's go through what we're going to do here today. I have a handful of slides to kind of set the baseline for what are we looking at. And then we will get into demo, and we can hopefully treat it as a little bit of a Q&A, make it a little interactive, and see some cool stuff. So we're going to talk about what are we solving for with build pipelines. So we'll dig right into build pipelines. We'll talk about some of the tooling that goes along with that. I have some specific ones that we use that I'm going to share as part of this presentation. But I do want to talk a bit about what other tooling can be used. There is a lot of options out there. They can, for the most part, be mix and match them. It is not necessary you use the tools that I'm using here. I happen to like the ones we use for the most part. Some of that may be I don't know what I don't know. But there are certainly lots of different options at many, many different price points. I'm going to talk about a day in the life of an OE developer, an OpenEdge developer with pipelines, and kind of just do a quick comparison of what does that look like and now without pipelines, and what does it look like now with pipelines, to get an idea of where benefits can be seen in your day-to-day. And then we'll do a live demo. We'll see how everybody knows how live demos go. I have a handful of different things to show, and then we'll walk right through it. We can see if anybody has questions or other things we want to try. We can use up as much time as we have available. Set some expectations for this session. The target audience is anyone who writes or is interested in code. I'm sure that we have, I know from talking with some of you, I know we have a lot of developers in this room. But it goes a little bit beyond that. Anybody who's interested in DevOps or having a quality product could certainly benefit. But certainly, we're gonna get pretty technical here. It's definitely geared at those who write code. Not to say that there's not takeaways for others. That is our primary audience here today. There's two different takeaways that I'm hoping you'll get. One is a basic understanding of pipelines. What is a pipeline? We haven't talked about any of that yet, so it may still be a mystery. So hopefully, by the time we're done, you can hopefully be able to talk about them, at least in a way to showing that you understand what their purpose is. I want to show that the value of build pipelines proves itself. I think, in my experience, I wouldn't want to work without them ever again. I think the quality that they help drive, simply none of us should be living without it. If we are, we're doing things the hard way. And hopefully what we see here, that will just prove itself. And then the last takeaway is, if you're not using build pipelines now, show of hands actually, how many people have build pipelines for compile testing? Okay, so we have quite a few. That's good to hear. If you are one of the ones that didn't have your hand up, I hope you'll be adding them as soon as possible. Well, let's get through it and you'll know why. So build pipelines, what are they? Build pipelines automate various activities, such as compilation. That's certainly the first one. We want to make sure our code compiles and generate binaries. Testing, I think this is certainly one of the bigger benefits to code quality. I mean, knowing that our code functions as we expect it to, and those tests pass all the time, is important. Packaging, they call that packaging in most languages. I don't know if Progress has a specific term for it, but basically taking the R code, putting it in, grouping it together so that it could be deployed, and then actually deploying that code. So these are all activities that could take place in a build pipeline. They don't all have to. So for example, we're not going to get to deployment or packaging today. I'll talk about where those can fit in. And even at my current company, we don't deploy from our build pipelines. Certainly it's on our roadmap of things to add. But basically, build pipelines it's activity automation. Testing. That was only one bullet point on that last slide, and I wanted to expand on that because there are many, many different types of tests. So I want to get a quick poll here. How many people in the room are running unit tests? Okay, how many people are running integration tests? Fewer. How many people are running performance tests? And the numbers dwindle. That's not very surprising. Some of these things are hard. Unit testing is hard. If you're not already doing it, that is a hard jump. Integration testing, same thing. And we can see here, I kind of spoiled the bullet points. But there's different types of testing that we can do with our build pipelines, unit testing being the easiest one. Integration testing gets much harder because now you are dealing with things outside of your primary application. But it is something that we can accomplish within our build pipelines. Same goes for performance testing. Now we have data concerns, so that's more we need to add to it. Vulnerability testing is fairly easy to have. We use a tool called Sneak. We'll talk about that a little bit more with tooling. But the main point I want to drive home is that build pipelines have the ability to add all sorts of different automated activities. Some are easier than others. If you are early on in your build pipeline journeys, or even if you're very far into it, don't expect to add everything all at once, but always keep in mind, what are we doing regularly that could be automated? And how do we get that into our pipelines so that it's not an activity we ever have to think about again? And we'll see some examples of some of those tests, at least two of them, maybe more. With tests, the next logical component is what we refer to as quality gates. I don't know if there is a better industry term. I know in GitHub, so what you're seeing in that screenshot there is GitHub calls them checks. Your checks have to pass before you can merge your pull request. But there's various different ways to do that depending on what your version control system is. I'm going to talk about GitHub specifically. I know that GitLab has different things. You may use other various source control systems. The idea isn't that there's necessarily pull requests. The idea is more so that there is a point in your development process where code does not get merged without having passed certain criteria. So for GitHub, that's GitHub and build pipelines. Our failed steps are preventing bad code from entering the code base. We're using pull requests to accomplish that with checks, but that is certainly not required. As I mentioned before, we still have more tooling to talk about. This could be done with any other type of tooling as well. We strive to incorporate tests for repeat issues. What I mean by that is when we see a problem in production, certainly if we can add a unit test, we want to do that. But we've also looked for ways to add other type of testings. That's how we've kind of gotten into adding some of our integration tests. We're not perfect. We don't have integration tests for everything that we interface with. But if we see something go wrong where somebody sends an event to Kafka that brings down a Kafka consumer, that's something we would likely add an integration test for. We might spin up a Docker container and test that exact scenario because we don't want that same problem happening in production ever again. So if you're using quality gates, try to think about them not as something where you're going to catch every single problem you have, but something where you can prevent problems from happening more than once. I talked about shift left at an earlier session. For those that haven't heard that term before, shift left is the concept of moving development activities to the left of the project management timeline. The idea being the earlier you have feedback, the better and more quickly an engineer can resolve that. So if a unit test is failing and they know about that before they push to GitHub, that's pretty much as far left as you can go. Whereas if we've merged and we've cut a release and then we run our unit tests before we ship to a customer, it's way too late in the process because now we have to go back to step one. Quality gates, build pipelines are a really great way to shift a lot of activities left, shift them earlier into the development process. And it all comes down to developer feedback. How can we give our engineers more information that they can use to write better code? I'm going to walk through the tools that we use to run our build pipelines. Some of this may look familiar, and then after this slide, we'll talk about some alternative tools. However, the process is going to be generally the same. It's certainly open to kind of whatever you can imagine. But realistically, I mean, this is a pretty generalized process flow, especially for OpenEdge. And I think you'd have trouble getting too far away from it. Not to say that you can't add more activities to it. This is just at a high level. So we start off in VS Code. Could be a different tool, just any IDE that you're writing code in. I personally prefer VS Code. So as an engineer, I'll come in, I'll write some code. I will push that code to GitHub. Again, could be any version control system of your choice. From there, I create a pull request, which kicks off a CircleCI. We use CircleCI as our job runner. So once it knows about that pull request, it's going to go tell CircleCI, hey, here's a commit ID. Go do something with it. From there, we also hit SonarCube to check if we have any deficiencies that can be known about from static code scanning. Don't have fancy arrows for them, but SonarCube and Circle will call back to GitHub, and you'll get either a green check or a red X, which we will see a bunch of here. But if all of that passes, and I get a code review, that's another activity in there, at that point, we're pretty confident that we can deploy. And deploy can mean a lot of different things. For us, that means merging to our main branch and pushing to our test environment. It may mean merging to a customer, depending on what you're doing. But essentially, what we're getting at here is we've passed the steps. Our code is at the highest quality we've been able to automate detection for. And I put an asterisk on that. It's that we've been able to automate detection for. So if you're not running unit tests, you're not scanning, yeah, your build pipelines are passing, but it's not telling you a lot. So the more testing activities you can add to that, the more confidence you have in the quality of those pull requests that get deployed. So tooling. There are a lot of different tools. This list, I usually like putting a screenshot of something on every slide, and I will warn you, one does not fit here. And this list is nowhere near complete. So for IDEs, I like VS Code. Certainly there's people in this room that use PDSOE. I would bet we can find somebody using VI, Emacs, Procedure Editor as their primary tools. Don't care what they are. Doesn't matter. Use whatever IDEs you want. Source control, again, I use GitHub. GitLab is another popular one. There may be somebody using SVN in this room. Nobody here has ever heard of the packet system. We have like an a homegrown source control tool that is a nightmare. You may have experienced some of those. But certainly, again, the source control tool of use does not matter. Build runner. We use CircleCI. What is a build runner? I didn't touch on that much. A build runner meaning it takes your code and runs some activities against it. So we use CircleCI. CircleCI has some free versions. We're going to look at, I'm demoing, we'll take a look at some of their freely available stuff. And you can certainly pay for higher levels of support on it and more volume, but we use CircleCI internally. We have an internal hosted instance, so we don't even have to share anything with the outside world. There's other ones though. GitHub Actions is becoming very, very popular. Very, very similar to CircleCI. It's basically just runs containers and you can do things with your code. I know Jenkins is very popular. I haven't used that in like 6 or 7 years. Jenkins is open source. And you have to maintain those instances yourself, but I think it's very popular. I bet there's some people in this room using it. I threw Azure DevOps in there. I've never used it. I don't think it's very popular. I think Microsoft's probably going to start pushing people completely towards GitHub Actions in the future. But there's other ones out there. You can find other build runners. Again, plug and play. Source code analysis. There's various different types of linting you can do, but realistically, especially for OpenEdge, SonarQube is going to be your scanner of choice. I don't know of any other one that supports it. I don't know of any other really good static code analysis tool. Not to say that there isn't one out there, just because I don't know about it doesn't mean it doesn't exist. So you certainly could plug and play there, but I do like and suggest SonarQube. Vulnerability scanner, this applies less to OpenEdge than maybe other languages, but that probably also depends on what your code does. If you're using a lot of .NET packages, this may be more important to you. We use Sneak. It's okay. It's the one we pay for. It works. It always seems to have a problem every time I need to use it, but it does tell us when a package that we are dependent on has a problem. When everybody in the room, I'm sure, is familiar with the log4j problem from last year, that thing just turned bright red, and yeah, that was fun. CodeQL, that's GitHub's thing. We've played around with it a little bit. That's another vulnerability scanner. If you're using Docker containers, Docker Scout. I think I've only played with it briefly lately, but it seems to do pretty good. Lastly, deployment tools. CircleCI, you can deploy from CircleCI. I don't love that concept, having your build runner also be your deployer, but it is very doable, and that's certainly something we do from time to time. If you're using Kubernetes, you're probably familiar with kubectl. Terraform, which isn't really deployment, but kind of is. Amazon Code Deploy if you're in AWS. I'd imagine a lot of us use some sort of shell scripts. to deploy, copy our code from one place to another. I think that regardless of what language you're developing in, I would be surprised to hear that there's too many companies that don't have a shell script somewhere in their deployment process. So as you can see though, that's a lot of different tools. For the most part, plug and play. There's obviously some configuration between each level. I will show you how we're doing it with CircleCI, but even the code that I'm using there can certainly be leveraged within some of these other tools. But the takeaway here is whatever tools you're using on this list, not on this list, build pipelines still apply. They're still going to be helpful for you. So there's 2 slides for this. We'll talk about a day in the life of an open edge engineer. So a lot of us, we wake up, we get to work. We have the worst part of our day, which is the morning meetings, stand-ups, and not writing code. And then we get into writing some code. Maybe we start testing, but then surprise, the second worst part of our day, more meetings pop up. Maybe we finish some testing after those meetings before lunch. That's not how my day usually goes, but I would like it to. And then we'll push our code. We'll eat some lunch. We'll pass a code review. We'll merge. And then what happens when we deploy? We end up with a bunch of bugs in our software because sometime in between those meetings, I was thinking about a test and I forgot about it. And I'm sure that sounds familiar to everybody in this room because that's how it goes. Notice there's no mention of build pipelines anywhere on this slide. This is definitely my life before my life and all of the other engineers I work with lives before we were able to implement pipelines. So let's take a look at, no bug popped up too soon, but let's take a look at a day in life with pipelines. What changes? Not a whole lot. We wake up, run through meetings, and I apologize if that's a little small. It's the same stuff, but new stuff in yellow. So again, worst part of the day, the meetings. Write some code, we'll start testing. Okay, another meeting coming up. Let me push it to GitHub. It's not ready yet, but I can push it up. I can create a pull request. There's no need to merge it. Might have some more meetings. I'll finish testing. Oh, but wait, when I pushed it to GitHub last time, it failed on a unit test that I didn't expect. Now I know to clean that up. I'll push my code after cleaning that up, finishing testing, lunch. I'll pass a code review, which is now faster because I don't have to hunt somebody down and they don't have to spend an hour reading it because they have confidence that SonarQube told them I didn't have spacing errors, I didn't have indexing errors. So it's easier for them. They can read through it, they can say, Ken, that's very readable and maintainable, and pass, and that doesn't always go that way, but in my dreams it does. And then I'll merge and we'll end up with a deployment that doesn't have a bug because I forgot to test something. And that's really where the value of build pipelines comes in. So let's do some live demo. That's the exciting part, right? Give me a moment. Let's get Docker started. We'll get some VS Code up. So for those of you that were in my session yesterday, this is the same repo. I'm using this. Oh, yep, that's no good. Thank you. Let's see. How do we stop sharing? Oh, that's better. So for those of you that were in my session yesterday, I'm using the same repo. For those that weren't, this repo is available in GitHub. It has various things from my talks yesterday about using VS Code, and it also has various things that we're going to look through right now as examples for running build pipelines. So feel free to go check it out. Beg, borrow, steal, whatever you want from it. Feel free to reach out and ask questions. But there's not a whole lot in here that makes all of what we're going to see work. Like I said, we use CircleCI. CircleCI uses YAML files. Who here likes using YAML files? Anybody? We have one. White space that means something is, I don't understand why we've gone backwards in time. But if you haven't used YAML files, they're really easy to complain about. They're not the worst thing in the world. CircleCI uses them, so therefore I use them. And what we see here, and we're going to see these actually run in Circle, is I have a hello world, because we're engineers. The first thing we write is hello world. So this is something that we will see in Circle. That's my first build step, so I'm not really testing anything, but I am proving that it runs. Another thing you'll see here is a Docker image. CircleCI only runs things with Docker. It's been, like I mentioned before, it's been a long time since I've used Jenkins. That may run just shell script space, I'm not sure. But I think most build pipelines these days are using some form of Docker to do things. For this hello world step, I'm just using their base image. There's no progress running. It's just saying hello world. My second step, though, this is where we get into progress. This is a job name. We'll see this name compile on the test. And is that big enough? Can I make that bigger? Let's make it a little bigger. Oh. So here I'm using, I talked about a Docker container yesterday. This is one that I built. It's the ones that Progress gives. If you go to Docker Hub, I just took their image and put a couple things on top of it. I could easily plug in their image here and change a couple things, but essentially use that out of the box. You do not have to go and start creating Docker images from scratch. I'll check out my code. That's just saying, what commit am I on? Give me that code. That's the stuff we want to test. And then I'm going to do a compile. We don't push, and you shouldn't be pushing your license keys into GitHub or anywhere else for that matter. We store errors here. This is a secret environment variable that me and only me has access to. And all I'm doing is writing that environment variable out to the progress.conf file. I should probably make that a different step here. But the thing you really want to take away is we're using ant compile. We're going to see that compiles, I think there's like 12 OpenEdge programs. And you know what? Let's just make this another step right now. So I need to change anyway, so I have something to push. So we'll make that a separate step. We'll do that, and I'll clean up the other one. And I don't need all this other descriptive stuff. Let's make this file as simple as possible. So I'm outputting my key, doing a compile, running my tests. Something to note here. You're going to want to compile once. There's no need to compile more than once. For this, I have only a handful of tests. They run very, very quick. The code base that I work on at work has 6 million lines of code and tests that would take 45 minutes, an hour to run sequentially. We run them on threads. So basically what we have is we have a job just like this. We have one that's compile, one that's test, and it says on test, split this across 6 threads, and it just knows how to do that. It just, what Circle will do is it'll say, here's all my tests. Okay, run 6 threads and just evenly divide those tests across those. 6 is the limit because that's what we have it set to internally, but we could certainly increase that. So if you have lots of tests, your build runner should make it pretty easy to basically, it's not threading in a true sense, but split that out so that you can gain performance. And that's not true of just testing, just unit testing. You could do that for integration tests. You could do that for validation tests. You could do it for compile if you wanted to compile different directories on different threads to make it faster. But certainly, it doesn't have to be sequential in this manner, and we can maybe take a look at that if we have time. Secondly, or lastly, third step, we're going to do a sonar scan. We're going to see, I literally stole this block right here from the sonar docs. SonarCube.com, look at their docs. How do I scan it? CircleCI gives you this. I'm using Sonar Cloud. We're not going to actually see OpenEdge results because Sonar Cloud only uses the languages that Sonar has decided are good enough, which OpenEdge is not and probably never will be. One of them, in reality, you will need a Sonar Cube server We run an enterprise one. There's other ways to do that, not very hard to set up. So if you, just a note, we will see how it scans the code regardless. To see that example, you're just not going to see any problems with the OpenEdge component reported. And then the workflow, all this does is tie it together, take those jobs, run say hello, run compile and test, run sonar scan, give it some context. Context in this case is the secrets to connect to Sonar Cloud. So let's take a look here. So I have a change here. I'm going to push this up. I'm going to commit this. For those that don't use VS Code, all I'm doing is I'm staging my changes. I'm saying this looks good. I've moved some stuff around. I'm going to write a very poor commit message, which I do more frequently than I should, but we use squash commits exclusively, so I don't feel too bad about it. But I'm committing this. It's going to save it. I got to put my secret code in, because you are signing your commits, right? And then I'm going to sync my changes. It's going to push it up to GitHub, and we'll go right to GitHub again, secret code. Has to know that it's me pushing, and then see if I can type it right. Maybe. Okay. And then let's go find GitHub. And you can see I was looking for dog pictures there. Sure. Go.
Is your compiler in your database image?
Yes, we were going to look at that right now. Yeah.
Okay.
Yeah. So Pug Challenge is my repo. And so this is my repo. I already have a pull request open for this. So it's going to push it and add it to that pull request, which is this one here. We see we got a red X. My build failed. I knew that was going to happen. And I promise we'll get to add the answer for that compile in about like 30 seconds. So I was cleaning up a lot of the files in this. This repo became a mess as I was preparing for this week. And I know that I've had many people talk about some of the things they want to be able to take a look at in here. So I'm using this pull request to clean it up. But the big part is I already had a pull request. I pushed up my change. Is it not here? I should have a commit from just a second ago. But anyways, we'll see some checks are not successful. CircleCI, let me make this a little bigger. I apologize. Is that better? Okay. So pull request, some checks are not successful. My compile and test failed. I know that my tests are failing. We'll take a look at that in just a moment. I never got to that Sonar Cloud or Sonar Scan step because if you looked at that config, it said that compile and test is required Sonar Scan. So if we don't pass our tests, we're not going to scan our code. A couple reasons for that is that SonarCube reports our code coverage percentages, and it needs the profiler output from the unit tests to know how much coverage you had. How can you report coverage if you haven't run anything to give you coverage? So that's why that has to come after that step. If you don't care about coverage, maybe you don't need that. My hello world step worked. That's nice. We can click on these, see details. If you're using different tooling, this may look different. The idea here, though, is that my merge pull request button does not work. I cannot merge this until I get passing tests. This is just a personal repo. I don't have code reviewers. In practice, a reviewer would be assigned to this on a round-robin schedule. This is an active open pull request. It's not a draft. It would get a code reviewer assigned. And all of our code reviewers know that if the pull request isn't passing the checks, why bother? Because you're going to have to look at it again anyway. Sometimes we might go in because somebody asks, hey, go look at this thing before I fix it up. But generally speaking, it saves us a lot of time. We're not re-reviewing over and over again because engineers are going through the process of fixing tests, of looking at the SonarCube results before it makes it to our code reviewer. But that would be another step here. Not required in this repo. It's just me. It doesn't even let you review your own code. But that would be another thing you can set in here. I talked about other types of tests. This list is 3 long. In our company, I think we have 7 required steps. Could have 15, as many as you want. Whatever you can dream up can be a checkbox here. And then from here, we can go to details, where then this is where we'll immediately look at that compile. So we can see this was that new thing I put in there. That was saving my secret value to my progress license. From there, it ran ant compile. I got a nice green check bar. Let me make this bigger again. Apologize. Saved out my, that's a setup step. You may have various setup steps. That's the one that I need for this repo, which is the container needs my secret. If it doesn't have my secret, it can't run. If you're hosting everything internally, you may be able to just put it in your container. Still wouldn't suggest it, but this is out public. You guys all have access to this. I'm not giving you my license key. Progress would not be happy with me. Although it is a classroom license key, so it's basically useless. From there, I run my compile. Somewhere in that compile step, I think in my, this would be in my ant build script, which we haven't looked at. If we have time, we can take a look at that. But I have an echo statement in there saying hello world. This isn't the hello world step, it's a different one. I'll probably take that out to avoid confusion, but we can see my code compiled. The way this works is this is that Docker container. This is the progress Docker container with the few changes I put on top of it. So once I give it my license key and it checks out my code, I can do a compilation in any way I see fit. If I wanted to write a program that runs, that uses the compile statement and loops through a directory, you can do that. I would highly suggest, if you're doing that, to learn how to use PCT compile, the progress compile tool, because it's going to save you worlds of headache later on. But at that point, you have progress. You have your code. Whatever you need to do to compile it can be done there. The R code from that can be saved as artifacts. So I don't have any here, but if we have time, we can add them. But there's no artifacts. I could zip that up, save it right here. Now I can download it. I can zip that up. I can SSH it somewhere else. I can email it, wherever that needs to go. And then the fun part, my tests fail because I wrote something, I changed something that made a unit test break somewhere else. That's actually not the case here. I would never write such poor code, no. But like I said, using the community edition license, for whatever reason, it lets you not do anything like read from the database. Why would you read from a progress database if you're trying to learn how to use progress? So it fails, and we'll change this. We're going to make this pass. I have total tests run 4. One of them failed. I don't know which one. One thing that would be really useful here, which I'll definitely add, probably not during this session, but before I merge this, is where's that results.xml file? There's a results.xml file that gets generated when we run our unit test to tell me which one failed. This message, not quite useful enough for me, doesn't tell me what failed. So that's certainly something I want to look for, because now I don't know which test to go look at. From there, so that failed, that stopped the thing, that stopped the whole thing, process stopped. Engineer, I know I need to go look at that. And an important component here is this took, from the time I pushed it up, it took 14 seconds to run, pretty much. We'll round up, we'll call it 20 seconds. I got that feedback immediately. I didn't have to wait for a nightly build to run. I didn't have to wait for a code reviewer. I got instant feedback. My trainer, I didn't go do something else, think about a whole different project, and then have to come back to this. I'm able to iterate within the work that I'm doing right now at my fingertips very, very quickly. Sometimes build pipelines can get long. I talked about our unit tests being split over threads. That's for that exact reason. At one point, I think our builds are taking 25 minutes. 25 minutes, I've got coffee, I've moved some tickets around, I've had an update meeting with my project manager, and I've maybe gone out for lunch in that time period. I've forgotten what I was working on. That's not useful. So something to think about if your pipelines are taking a while, how do we make them faster? If we have really long steps, how do we build them in later in the process? Let's get the most valuable information out first. We can see the here, This is a workflow. Workflow is the terminology used by CircleCI for a pipe. I like the word pipeline. I think that's much more common. They call them pipelines somewhere interchangeably in their documentation, which I find interesting. But essentially, what this is showing is that hello world step ran and passed. My compile and test step failed, and then my sonar scan step never ran. So maybe let's fix that. What does that look like? I'm going to be a really bad engineer here, and I'm going to simply comment out that test case, if I can figure out which one it is. Not secrets, so I have tests. I think it may be, it's not that one. Could be this one. No, I think it's this one. And this is where having that output that told me which ones were any good would have been helpful. I am just going to comment out the test attribute or annotation, and let's just see. Let's see if that will make my test pass. We can see here, if I go to my branch, so that was run 10 minutes ago. Assuming that this passes here. Did I type it wrong again? So we have, that was the one that just ran. This should update in just a moment. So we can see that popped up automatically. I know it's sometimes easier to see when you have it on your screen because you can see the list of all the ones that ran. But you can see this updated. I pushed that commit. GitHub told CircleCI about it. CircleCI starts doing its thing. There is nothing manual to do. A lot of times I will push something, be thinking about what else I need to change, and I'll get the email with the results before I have time to go out and look for it. And I guessed right. My test passed. That's wonderful. I mean, it kind of passed. I did the bad thing. I commented it out. So total test run, it ran 2 instead of whatever it was trying to run. I still got an error. It's, again, community edition. Ignore that. This in practice, though, this error would fail our pipelines. We have detection for things like that. So if you, I think we look for the ** space starting a line. If we see that, we're going to fail your pipeline regardless of what the test said, because we don't want to see errors in our output. We are very strict on that. You may do the same. You may scan your log files as part of this. We do that as well. So certainly there's additional things on top of just the tests pass that you can look for here. Lastly, let's see. My whole pipeline passed. I have a sonar scan that passed as well. We can take a look there. This is going to look very, very, very similar to what you would see if you were using Sonar Cube. All this does is, if you're familiar with Sonar, or even if you're not, it just runs the tool called sonar-scanner. It's doing it inside of their Docker container. You don't have to use their Docker container anywhere where you have the Sonar scanner available, which is just a simple download. You can run this. We're using the Ant plugin. I recently learned that that's deprecated though, so we're probably going to switch that. Maven has a plugin. I know Gradle has a plugin. There's a Java jar file that you can download and run. It's very, very easy to get if you want to run it in another manner. Nothing too important in here, but we can see it, basically what it does is it just goes through, indexes my files. We can see there's some sensors for C# and HTML and text and secrets. And I can run this locally to a Docker container and actually get results for OpenEdge. It's just for the sake of purpose and pushing this out to the internet where you can see it. We're not going to see anything for OpenEdge here. But you would see exactly the same thing with like maybe 10 more lines that said something about OpenEdge and maybe failures. But analysis successful. What do we do from there? And we'll see this on our pull requests, but from right here you can click on it and log in. And we can see my quality gate passed again. It's not really scanning a whole lot. It's got my code there. It knows about the progress code. It just doesn't know what to do with it. But that's it's just SonarCube doing its thing. Oh, I'm sorry. I know I keep forgetting that it needs to be bigger. But what we see, this is like really important part. If all that passes, I'm not going into SonarCube. I'm looking here. I'm looking to say, what does it say on my pull request? Because SonarCube is going to call back to your pull request. It's going to say, oh, you have a bug. And it's going to put a big red X on it. You can't merge. But that's not the case here. I have 0 bugs, 0 vulnerabilities. This is what we look for. We actually have a rule that you have to have 80% coverage on new code. I don't have any coverage information here because it's not importing. Oh, whoopsies. But in my professional world, we have an 80% rule. If you don't have 80% coverage on new code, it's not even going to give you the button. You're never going to be able to merge. So go back and write more unit tests. You can set rules on duplication. These are the bugs, vulnerabilities, hotspots, code smells are basically, you can think of them as categorization, but also there's severity level that can be associated with different rules, so you can decide what's important to us. You're not stuck with just, oh, that's what somebody thinks. You have lots of room for configuration there. And I got my big green margin pull request button. Normally this would ask, it would say, everything be green, merge button wouldn't be available, because it would say I need at least 1 reviewer, or 2 reviewers for us. We have to have 2 reviewers on every pull request to make our auditors happy. And until I got those people to come in and say approve, I wouldn't be able to merge, but I do have that. I'm going to go ahead and do it, just show what that looks like. Because everything passed. My build pipeline there basically told me, you have a failing unit test, you need to fix it, go push that. In reality, I'm a bad engineer. I reduced our coverage because I took out a unit test. It's not running anymore. It's useless code. But you can get a feel for, that's how we turn around. We go back, we look at our tests, we fix them, push them up, and then see new results. Real quick, I want to get this, ask questions while we still have time left. There's one more thing I want to show. So all of that was choreographed with CircleCI. That's just that config file. There's a README file in here talking about my conversion things that I'm actually going to change and make smaller and simpler. They're not important. You don't need those. You'll need something to get your keys up there, but that's not the important takeaway. The other part here, the part that is important is the Docker file. In most cases, you're likely going to end up using Docker to have your build pipelines run. Not to say that Jenkins couldn't call out to a server that has progress installed, copy code to it and run it. You could do that. But I would question why you're spending your time setting up a server when you could set up a Docker container that is much, much more repeatable. But again, very configurable. You got lots of different options. But I just wanted to show this is really easy to set up, and I don't even need to do any of this here. All of the steps in this Docker file are because I want it to run faster. So I've taken the Progress software container from Docker Hub, and I've installed Java because it doesn't ship with Java. I've copied the latest version of PCT, etc. This could all be done inside that Circle thing, inside that Circle file. You'll see often in other languages you'll do something. If you use something called a SonarCube orb, it's basically just a function that does something. It may install a piece of software for JSON analysis, and it'll do that on the fly. Installing Java is a little slow. It's not unreasonable to do that on the fly. I much prefer to set up a container and have that ready because I can run this container locally and get exactly the same results. So a couple different options there. You're not stuck with configuring a container exactly like this, but it certainly sets a footprint for you that you may be able to use. So one of the things I do here is I install the ABL unit procedure library because that doesn't come in that container. So I can run my unit tests with the ABL unit code. You can add any other thing that you need here. If you need to add something to run Kafka, you could put that in here. If you need to add some .NET libraries that you use, you could put that in here. Basically put all of your dependencies in the container ahead of time so that you're not trying to configure them on the fly. You know what they are. You have a good inventory of what they are. And it's just super, super clear to your engineers what is needed to execute your code, because it's right here in the repo. It's right here in the Docker file. Need more stuff. This will shrink before I really have this repo cleaned up. I mean, it's all usable now. Don't be scared off from that. I am just love constantly iterating through improving things. I'm going to try and make this even simpler for anybody who wants to take a look at it and use it, because I think the cleaner it is, the clearer it is for somebody trying to mimic any sort of pipeline. And that is about it. I have one more slide I'm going to pop up. We can come right back to VS Code and ask questions, though. Let me just do this real quick. But just quick summary, quick takeaway. Another picture of my beautiful dog. Build pipelines, they're your best friend. If you have problems where you have the same problems entering production or getting to a client regularly, your solution is build pipelines. I don't know of another one that's going to get you there, period. I do not know how you can solve repetitive problems without a repetitive solution. It will not happen. You will not rely on code reviewers enough to say, we're not doing this anymore, and it's never going to happen. You cannot rely on humans to do that. We are not good at consistency. Faster development, less error prone, feedback loop, much, much faster. I know about my unit test failures immediately. I don't know about them tomorrow morning. I've certainly worked in that environment, and I can confidently say that when we were running unit tests nightly, actually we were running them every 6 hours, there wasn't a single day where everyone passed. That never happened. And they never got fixed. We still have some that are broken that we've just obsoleted because it's not even worth it. But going forward, that has not happened. You can't merge with a failure, so all of our unit tests pass all the time, and it has prevented hundreds of problems from entering production. Shift left developer feedback, same thing. Get that information early. You make a compile. You change a field in an include that has a temp table. You change a field on a temp table to include, and that causes a problem in some file in another package that you're not even developing. You know about that right away. You don't have to wait for a nightly compile. So you're just getting that information quicker. And really it's providing confidence. Confidence to deploy quality code. We know what we're deploying was tested. We know we're not going to have that same problem we deployed last week, because that problem we found when we deployed last week has a test for it. Make that problem go away forever. Build pipelines are going to get you there. So I hope you enjoyed this. I have time for questions, and we can go look at more code. But thank you for coming, and hope you enjoyed it. So anybody have questions, anything else we want to see?
How long is your build, your extra build at work?
So we have two types. So our pull request builds are down to 4.5 minutes. We have done various things. So running the unit tests against the R code only should put them in about half speed. We also run them on 6 threads. The biggest problem is SonarQube takes like 45 seconds because for whatever reason, SonarQube believes they have to scan every language they know about. So they pull down a bunch of jar files and they won't cache them, so that takes a while. But generally for a pull request, they're getting feedback. If it passes, it'll take 4.5 minutes. If compile fails, they'll know about that in about 30 seconds. Unit tests fails, they'll know about it with 2 minutes max. And then if Sonar fails, it's like 4.5 minutes. So pretty quick. We run a nightly scan of SonarQube, and we do all of our tests, basically compile from scratch. Normally, the pull requests are just incremental. When we start from scratch and we compile all of 6 million lines of code, run the tests, run Sonar for every single line of code instead of what changed, then we're at about 30 minutes for the pipeline to run. So it's definitely slower. I would consider that untenable for pull requests, but there's plenty of options to say, hey, let's just look at what changed within a pull request. So, and even we had it at 10 minutes not that long ago. The engineers didn't love it, but it was quick enough that we were getting the benefits. Not so quick that we didn't want to make them faster, hence why we got them down to about 4.5. So certainly that turnaround time is important. Yeah.
What did you do to speed them up?
The R code was one. We wrote some code to basically determine, let's say you change an include file. Go figure out what classes, what .ps and everything are related to that, and then delete everything else. Yeah, it's a little primitive, but basically just shrinking the repo to what do we need to run, and that helped a lot. Threading the unit tests helped. Analyzing the unit tests to see which ones were taking a really long time, so we can not run those basically, or figure out why is we have a set of classes that control some of the database interaction, and they have automated test cases with them because they're generated code. Well, they're never going to fail, and they were taking 6 minutes to run. Why are we doing that every time? And we were able to basically just rewrite those to get unit tests that got exact same feedback, but ran in like 2 seconds. So that was a part of it. Really just analyzing what's running. Much like you would use the performance profiler to just profile your progress application, take a look at the steps that are running, break it down, figure out where it's taking a while, and then do the same thing, go from there. And if it's the unit test, you get the profiler output, so you are literally just doing the same thing.
You can find the results of that.
What's that?
If you can find the results of that.
Yeah, if I'm properly uploading my artifacts.
So how do you achieve the threading with that? Is it like an AND feature?
It is, where are we going here? I will Google it. So CircleCI, it's not called threads. Well, maybe it is. Test splitting and parallelism. This is just a feature of our build runner. So literally, one of the things that we do when we run tests is that the results.xml, I want it as an artifact so I can see it. But because it's in a JUnit format, it gets uploaded, and CircleCI has a little green thing that says you ran 11,000 tests, and a little red one that says you failed one. But part of that means that CircleCI is aware of which tests we have. So what we can do is when we set this up, we can give it, basically all we do is we say parallelism 4. It knows about our tests, and you can tell it to split it like just evenly. Each one gets 1/4, or it can split them by timing. We didn't like the timing one because we have a cardinal sin of data issues. So when they mismatched, we got different failures that didn't make sense. So we just split them the first quarter, second quarter, third quarter, etc. So it's really just in that CircleCI, we add that. I would imagine other tools have similar things. I don't know what Jenkins looks like. That may be a little harder. But realistic, I mean, you can also just write like a script that says, or maybe even have 4 files in your repo that say, these are the tests from thread 1, run that one. These are the tests from thread 2, and just run them simultaneously. So it's not, even if you have to do it manually, it's not a ton of config. We've done that before, and it wasn't a huge burden. Right, yeah. Certainly something you need to be aware of. But if they are, I'd question why they're in different files anyway. But I understand that certainly is something we come across from time to time. So, yeah, when the data from one test, or when one test relies on the output data from another test, you're really setting yourself up for hating yourself in the future. I know that from experience all too well. Any other questions? All right. Yeah, I'm hungry. Thank you all. Thank you again.